Hello students, today's topic is SQC, that is Statistical Quality Control, and Statistical Quality Control Tools, that is about the process variability. So we will learn what is Statistical Quality Control, its tools, and also the process variability. So SQC, or Statistical Quality Control, is a term which is used to describe a set of statistical tools used by the quality professionals. So this is a term used to describe set of statistical tools used by the quality professionals. So this statistical quality control can be divided into three categories. What are they? The first one is the descriptive statistics. Descriptive statistics are used to describe the quality characteristics and relationships. So, they are describing the quality characteristics. As the name indicates, they are used to describe the quality characteristics and relationships. So here in descriptive statistics, the statistics like mean, standard deviation, range, and the measure of distribution of data, range and the measure of distribution of data are included. Statistics like mean, standard deviation, range, and measure of distribution of data is included. The next category is the statistical process control. So, statistical process control involves inspecting a random sample of the output from the process and deciding whether the process is producing product with characteristics that fall within a predetermined range. So in statistical process control, there is a control limit within which these characteristics of the product has to fall. So we will check here whether the process with which we are producing the product is seeing to it that the product is within the predetermined range or within the control limits. So here we will inspect a random sample. So first we will receive an output from the process, that is a product which is being manufactured is received, and then we will decide whether the process is producing the products with characteristics that fall within a predetermined range or not. So this statistical process control will answer the questions of whether this process is functioning properly or not. So from this statistical process control, we can know if the process is functioning properly or not. So the last one, that is the acceptance sampling. So acceptance sampling is a process of randomly inspecting a sample of goods and deciding whether to accept the entire lot based on the result. So for example, if there are some 1,000 products or goods which are produced. So from that 1000 products we will collect some 10 products and we will inspect these products. So if all the products in this sample are good enough, then we will accept the all the 1000 products. If not, we will reject all the 1000 products. So that is all about the acceptance sampling. So here we will randomly select the samples. Acceptance sampling determines whether a batch of goods should be accepted or rejected. The tool in each of these categories provide different types of information which is used to analyze the data. So all these three subcategories of statistical quality control have different kinds of tools. So the tools in each of these categories provide different type of information about the quality of the product, which can be used to analyze the quality. So descriptive statistics are used to describe certain quality characteristics like the central tendency and the variability of the observed data. So descriptive statistics are used to describe quality characteristics. What are they? Like the central tendency and variability of observed data. So this descriptive statistics may be useful to understand the variability, but they are not enough to help us to evaluate whether there is a problem with quality. So they do not help to evaluate whether there is problem with quality. Acceptance sampling helps us to evaluate the problems with the quality. It helps us to decide whether desirable quality has been achieved for a batch of product. So we can decide batch of the product. We can even decide whether to accept or reject the items. So here whether to accept or reject the items. So this acceptance sampling helps us to decide the quality acceptance decision after the product has been produced. So acceptance sampling is applicable only after the product has been produced, but it does not help us to identify and catch the quality problem during the production process. So acceptance sampling does not help to identify the quality problem during the production process. So for this, that is statistical process control helps us to identify the quality problems during the production process. So all these three, that is the statistical process control, descriptive statistics and acceptance sampling, are helpful in measuring and evaluating the quality of the product or services. But statistical process control tools are used most frequently because they identify the quality problems during the production process. So statistical process control tools most frequently used to identify quality problems during production. So these tools which we are going to learn, they not only measure the value of the quality characteristics, they also help us to identify a change or variation in some quality characteristics of the product or process. So these quality control tools, now variations in the production process will lead to quality defects and lack of product consistency. So variations in the production process leads to quality defects and lack of product consistency. That is why we have to see that the variations have to be completely avoided. So now let us learn what are the sources of variations. Once we know the sources of variation, we can easily analyze how these statistical quality control tools can help us to check for the process variability. Now, sources for variability. Variation. Here we will know the common and assignable causes. So, a statistic that will measure the central tendency of a set of data. So, here we will take up an example. If you look at the bottles of soft drink in any shop, you will notice that no two bottles are filled exactly to the same level. So, there may be variations in the level to which they are filled. Some are filled slightly higher and some are slightly lower. So these type of differences are completely normal. So no two products can be made exactly alike because there will be differences in the material, the workers who are working on making the product, the machines, the tools and other factors. So these are called as common or random causes of variation. So here a statistic that measures the central tendency of a set of data. So two products cannot be made exactly alike because there will be variations in materials, workers, machines, tools and other factors. So these kind of variations are called common or random causes of variation. These are common or random causes of variations. So the common causes of variation are based on the random causes that we cannot identify. These type of variations are unavoidable and are due to slight differences in the processing. They are random causes. We cannot identify them and they are unavoidable and they are due to slight differences in the processing of the product. So to control the quality or for quality control, it is very important to find out the range of natural random variation in the process. So here we have known that the common or random causes for variation. So we have to know the range of them, how much they are varying. So it is important to find the range of random variations in the process for quality control. So, for example, we have taken the example of the soft drink bottles. So, if the average bottle of a soft drink has 16 ounces of liquid, we may determine the amount of natural variation is 15.8 and 16.2 ounce. So, if this were the case, we would monitor the production process to make sure that the amount stays within this range. So, for the soft drinks, I have told you there will be variations in the filling of the liquid. Some may be highly filled, some may be filled less. Now, let us consider a range. Let us give a range of, so if the soft drink bottle, this is the example of a soft drink, contains, so if this is the standard 16 ounce, let us consider this as the standard. So amount of natural variation, that is the range which we are giving, let it be is between 15.8 and 16.2. Actually it must be filled to 16 ounce, but we cannot fill it exactly, so we are giving a range which may be 15.8. It may be filled up to 15.8 or it may be filled up to 16.2. If it is within this range, then we can say that the variation is not big and we can accept the product. So if the production goes out of this range, so let us consider it was found that on an average the bottles contained 15.6 ounce. So production goes out of range. So the range is 15.6 to 16.2. Here 15.8 to 15.6, but here the filling or the ons up to which it is filled is 15.6. So it is out of this range which we had already decided. So then it will lead us to believe that there is a problem with this process because the variation is greater than the natural random variation. So here the process has problem because variation is greater. Natural random variation. So we know the common or random causes of variation. The second type of variation that we can observe involves those where the causes can be precisely identified and eliminated. So I have already told you the random variations or the common variations, we cannot identify them and they are unavoidable. Here the second type of variations, that is the assignable causes of variation, can be easily identified and they can be eliminated. So it involves those causes which can be identified and eliminated. So causes for these variations can be easily identified and they can be eliminated, and they are called as assignable causes of variation. So example for these type of causes or these type of variation are poor quality in raw material, or an employee who is needing more training, or a machine which is in need of repair. So in such examples which I have given you, the problem can be identified and corrected. So examples for assignable causes of variation: poor quality raw material, employee who is unskilled, or who needs training, or machine requiring a repair. So these type of causes can be identified and they can be corrected, or problems can be identified and corrected. So if this variation is allowed to persist, that if we do not solve these problems, then what happens? Then it will create problem in the quality of the product. For example, if the soft drink bottling operation, which the bottle has the low or the greater variation, which I have given an example as 15.6 ounce, then it will signal a problem. So the machine may need to be readjusted, an assignable cause of variation. So these assignable causes, if they are not corrected, then they will lead to problem. So we will get into the tools of SQC, that is the statistical quality control tools. So we have already discussed the different categories of SQC. The first one was the descriptive statistics. So as we have already discussed, this descriptive statistic will describe certain characteristics of the product and a process. So the most important descriptive characteristics or descriptive statistics are measure of central tendency. Like, so the tools which are involved under this descriptive statistics is, the first one is the mean, then the range and the standard deviation, range and standard deviation. Then the third one is the distribution of data. So here the first one, that is the mean. So in the soft drink bottle example, we stated that the average bottle is filled with 16 ounces of liquid. So the arithmetic average or the mean is the statistic that measures the central tendency of a set of data. Arithmetic average or mean is the statistic that measures the central tendency of a set of data. So knowing the center point of a set of data is very important. So to compute the mean, we have to sum all the observations and divide by the total number of observation. So to compute mean, we must sum all the observations and divide by the number of observations, total number of observations. The next one is the range and the standard deviation. So here again, let us take the bottling example. So we said that there was a duration or the natural variation in the bottle process we had taken as the variations can be within 15.8 and 16.2 ounce. So this information provides us with the amount of variability of the data. So we can say how the spread out the data are around the mean. So by this we have given two limits. Okay, so it can be within this limit. So that limit is the first measure. There are two measures that can be used to determine the amount of variation in the data. The first measure is the range, which is the difference between the largest and the smallest example. So in our example, the range for the natural variation is given as 0.4 ons. The other measure is the standard deviation. So here we had taken the example of the soft drink bottle and we had given, so here we can make two measurements for the variability of the data. First is the range, that is the difference between largest and smallest observation. So in this example, that is 15.8 and 16.2, the largest is the 16.2 observation and the smallest is the 15.8, that will give us 0.4 ons. So this is the range in this example. The other measure is the standard deviation. So the other measure for variation other than range is the standard deviation. The next one is the distribution of data. So the third descriptive statistic used to measure the quality characteristic is the shape of the distribution of the observed data. So when this distribution is symmetric, there are the same number of observation above and below the mean. So here in descriptive statistic, to measure the quality characteristic, we consider the shape of the data which is distributed above and below the mean. So when distribution is symmetric, there are the same number of observations above and below the mean. So if there is normal variation, the distribution of the observations above and below the mean will be same, or the distribution will be symmetric. So when a disappropriate number of observations are above or below the mean, we say that the data have a skewed distribution. So in skewed distribution, there are disproportionate number of observations above and below the mean. Now the statistical process control methods. So we have already seen the descriptive statistics. Now we will see the statistical process control methods. So this statistical process control employs descriptive statistic to monitor the quality of the product or processes. So the different types of variations, that is the common and assignable causes for variation, are present in every production process. So using this statistical process control, we will determine the amount of variation that is common or normal. So by using these statistical process control methods, we determine the amount of variation that is common or normal. Then we monitor the production process to make sure that the production stays within the normal range. So after we identify whether the variation is common or normal, we will make sure that the production process stays or the production stays within the normal range. So we make sure that the process is in state of control. So here we say that the process is in state of control. The most commonly used tools for monitoring this production process is the control charts. So the statistical process control uses the tool is the control chart. So now we will learn about the developing of the control charts. So a control chart, which is also called as a process chart or it is called as a quality control chart, is a graph that shows whether a sample of data falls within the common or normal range of variation. So a control chart, it is also called process chart or quality control chart. So it is a graph that will show whether a sample of data so we can define control chart as the graph that shows whether a sample of data falls within normal or common range of variation. So the control chart has a upper limit and a lower limit that will separate common from assignable causes of variation. Control charts have upper limit and lower limit that separate common from or random causes from assignable causes for variation. The common range of variation is defined by use of the control chart limit. So we can see if the variations or the range of variation is between these two limits, that is the upper and the lower limit. If they are well between the upper and the lower limit, then we can say that they are in the common range of variation or they are in normal range of variation. We say that the process is out of control when the plot of data reveals that one or more samples fall out of the common limits. If the plot of data is between these upper limit and lower limit, then we can say that the process is under control. If the plot of the data reveals that one or more samples fall out of or outside the control limits, then we say that the process is out of control. So these control charts are a very important SPC tool which is used for controlling the quality in an industry or in any manufacturing firm. So, control charts are of different types. So, there are control charts for variables and there are control charts for attributes. So, we will discuss the details of these charts in the coming topics. I will just list out the control charts which are for variables and for attributes. So, control charts for variables. So, the mean X bar chart or the mean chart is the control chart for variable. That is the X bar chart. The next one is the range chart. That is the R chart. So these are, we will get into the details of these charts one by one in the coming topics. So we can use this mean and range chart together also. Now, using the mean and range chart together. So how and when we are going to use them, we will discuss later. Now, control charts for attributes. The two most common type of charts for control charts for attributes are the P chart and the C chart. So what does these charts do? We will discuss later. So P charts are used when the observations are placed in either of the following two groups, that is to check if the samples are defective or not defective, whether they are good or not bad, and to check whether they are broken or not broken. So C charts are used when the defects can be counted per unit of measure. For example, if you want to find the number of dents per item, then we can use this C charts. So this is about the SQC, that is the statistical quality control tools. So we have discussed the different types of statistic control categories, that is the descriptive statistic, then we have the statistical quality control or statistical control process, then we have the last one, that is the acceptance sampling. So all these statistical categories have certain tools, like for the descriptive statistic we have the mean, the range and the standard deviation. Then for the statistical process control method we have the control charts, and there are different types of control charts. The same way, for the this statistical control process will use the sampling technique to see that the product which we are producing is of good quality or of very high quality. So the last topic which we are going to discuss here is process capability. So we have discussed many ways of monitoring the production process to see that the production process is in the state of control and there are no assignable causes of variation. But a critical aspect of statistical control, quality control, is evaluating the ability of production process to meet or to exceed the preset specifications. So, a critical aspect of statistical quality control, evaluating the ability of a production process to meet or exceed the preset specification. So there are specifications which are already set before the manufacturing of this process. So this critical aspect of this statistical quality control for evaluating the ability of the production process. So we are using a particular production process to produce this product. So we have to check whether this production process is able to meet or is it exceeding the preset specification. So this is called as the process capability. So we already know what are specifications. What is meant by specifications? So to understand what is process capability, we have to know what is specification. So product specification, often they are called as tolerance. They may be tolerance. They are the preset range of acceptable quality characteristics such as the product dimensions. So this is the preset range of. So I have already told these specifications are set based on the customer's requirement or customer's need. So we have already learned that any production process has certain natural variations associated to it. It cannot be completely perfect. So to produce an acceptable product, the process variation should not exceed the preset specifications. So process capability involves in evaluating process variability relative to the preset product specification in order to determine whether the process is capable of producing an acceptable process or not. So process capability is evaluating process variability, that is how much it is varying from the specification relative to the preset product specification to determine whether the process is acceptable for producing the product. So this is all about the statistical quality control, its tools and process variability. I hope you have understood the topic. Thank you.